In scientific research, the holy grail is causation. However, it is not an easy treasure to find. We are often told that correlation does not equal causation. However, in the field of food science, we are constantly searching for causation of long-term health problems and diseases due to the food we consume. So how do we know when it is causation and when it is just correlation? Today we will explore 5 different criteria for causation and some common explanations for correlation. Causation is the relationship of cause and effect. A causal relationship needs to be somewhat proven before a recommendation can be made for nutritional epidemiology. One of the scales used to weigh causality is the Bradford-Hill causal criteria. This is composed of 5 different sections. These sections are consistency of association, strength of association, dose response, biological plausibility, and temporality. Consistency of association. Can the results obtained be replicated across different people, different sampling frames, in different settings, and using slightly different methods? For example, simple carbohydrates will always cause a blood sugar spike in healthy individuals and an insulin spike that follows quickly after. This is true regardless of ethnicity and physical location in the world. Next is strength of association. How strong is the reaction tied to a certain treatment? Typically, in food science, a response greater than 20% increased risk is significant. But just using strength of association in order to make a nutritional recommendation is a gray area in some cases where a proposed recommendation may cause other health risks. Third is dose response. If treatment and response is correlated, then a change in the treatment should result in a change in the response as well for a causal relationship. For example, fewer grams of sugar consumed should result in a lower rise in blood glucose level. This is straightforward, but it can get complicated due to threshold effects, where the body will not absorb more than a certain amount and will not excrete more than a certain amount of a nutrient at once. Fourth, biological plausibility. Does the mechanism of action make sense for a causal relationship? Is the mechanism understood or even biologically possible? Finally, temporality. Exposure should always precede the outcome. The order of time matters. If you get the grade back for your midterm before you take the midterm, something is wrong with the exam. Aside from causation, there are some potential explanations for association between variables. These are the cause-effect, effect-cause, chance error, bias error, confounding effect, effect modification, and interaction effect associations. They can either be real associations or spurious false associations. Causation is a correctly identified cause-effect association. This means it is a real association. X really does cause Y. Let's start with the effect-cause association. The effect-cause association is a real association. However, the hypothesized treatment and results were switched. An example would be believing that scurvy causes vitamin C deficiency, when in reality, vitamin C deficiency causes scurvy. Chance or random error is a false association that may result in data that looks like causation. This includes error in data collection that can occur from faulty code in the analysis program, misinterpreted questions, or misinterpreted answers on the part of the interviewer. Bias or systematic error is also a false association that can result in bogus data that looks like correlation. This is typically by design of the researchers or by an unconscious bias of researchers. These errors are typically consistent throughout a study or even a group of studies by a single or a group of researchers. These problems can be found through critical analysis of methods as well as comparison of its results and findings to other similar research. Confounding association is a real association where causation is present. However, neither the treatment nor the outcome are the causes, but rather a third outside factor causes both the treatment and the outcome. For example, the theory may be that X causes Y. However, a third variable, Z, causes both x and y to occur. Effect modification association is when the strength of association actually varies depending on a third variable. This is a real association, but differs from confounding association, as the third variable is not what causes the outcome, but rather the treatment as well as the third variable in conjunction causing the third outcome. For example, in a situation where caffeine intake only correlates with higher GPA during the morning. In this case, the treatment of caffeine causes a higher GPA, but only during morning classes. Lastly is the interaction effect. This is also a real association where two or more independent variables are able to interact with each other and act on one or more dependent variables and causes a far greater effect. In summary, we learned about the 5 different criteria in the Bradford-Hill causal criteria and how to differentiate and give examples of potential explanations of associations between variables.